Good morning, my dear students. In today's class, in the chapter center of mass, we are going to discuss how to find out the center of mass of like a hemispherical shell, solid hemisphere, cone, and if some hole or some cavities made in solid objects, how to get the center of mass. Then after that, we'll go for the motion of center of mass, which is the central part of this week's syllabus. Okay, let me start the class. Now, previous class we had a discussion about the finding the center of mass of the various objects. If you can remember, so we have started with a rod, then we came for semicircular wire, semicircular arc. So it was all some mathematics, no? The basic definition mathematics. Now we'll try to find out for other objects hemispherical shell. Carry on now. We have to find out the center of mass of hemispherical shell. I think everyone knows what do you mean by hemispherical shell, how it will be. Okay, hollow. So this will be hemispherical shell. So now the center of mass of this has to be determined here. Keep it aside. So the hemispherical shell. So the radius of this, let it be r. Let's see now. Now what is the basic method here? So what is that elemental structure you are going to assume matters a lot, no? Keep it below. This will be y-axis. So here we'll assume an elemental structure. So what is elemental structure I should assume? I should assume elemental structure to be ring. That elemental structure, three-dimensional not possible. Okay, I'll do one thing. Rough diagram I'll give it. This is that elemental structure. Carry on. Meanwhile, I'll adjust the diagram. It should be like this. So other side will come in this. Okay, here this elemental ring is what we assumed it. So let the radius of this ring, let it be r. The radius of this total is capital R. Then it will subtend an angle. So this should be theta. This will be theta. This will be dl. So this height will be r cos theta. So what is this? This is an elemental ring, and this everything is a hemispherical shell. I think lemon, you cut it and after squeezing, so what do we get inside the hollow region? No, that's what the hemispherical shell it is called as. Okay, fine. Now the mass of this elemental structure, let it be dm. Elemental ring, elemental structure, what all you can, if you can call it. So where the mass is present only on the surface, no, let m be the mass. Then what we define? We define sigma m by 2 pi r square. We define like this. What is this? Area density, mass by surface area of hemispherical shell. Half of the surface of a hollow sphere. So 2 pi r square will come, the surface area. So what is the surface area now? So this is what the area now. The green color surface area, how much will be? 2 pi r square. solid hemisphere, hemispherical shell. Difference you must know, very, very important it is for us. First we'll define the mass of hemispherical elemental ring. Mass of dm. So what is dm should be equal to sigma into the perimeter of this ring is how much? 2 pi r into dl. So what is radius r? Radius r, I think we can define it, sine theta equal to small r by capital R. So therefore this will be 2 pi sigma small r equal to r sine theta dl. dl what we can write? r d theta. 2 pi sigma r square sine theta d theta. This is the mass of elemental ring. Let's go for the basic definition. Further, sigma into 2 pi r square, what we can write? This has m, so this will become total m sine theta d theta. Then what is the definition? The center of mass should be equal to ycm. Now, the center of mass of elemental structure, where it is at a distance of r cos theta, into dm by total mass. What should be the limit? Okay,
Zero to capital R, sir.
wait. Let me tell assign it. Now, sir, what is this one? The center of mass of elemental ring, where it will be? Center of mass of center of this will be O, we'll call it. Center of mass of hemispherical shell will be somewhere here. What is this in the definition? Center of mass of elemental structure. So once again, what is this? Center of mass of elemental structure. I think this will be very easy if you can manage this one. So dm is m sine theta d theta by integral of dm will be total mass. So we'll go for sine theta cos theta d theta. Now let me adjust 2 r by 2m 2 sine theta cos theta d theta. Now what should be the limit? This is very important. This is what a student has to put effort here. How to get the center of mass of the, what should be the limit here? See, I assumed a ring, that one. Shall I make 0 to, this is theta, no? 0 to pi or 0 to pi by 2? If I rotate, see, I defined a ring. If I rotate 0 to pi by 2, what do I get? I get a ring, no? But sir, like, why you are not taking limit? I didn't define half of the ring. I defined one full ring. So what should be the limit here now? 0 to pi by 2. Solving this, integral of sine 2 theta r by 2m minus 1 by 2 cos 2 theta r by 4m one this 2m will get cancelled, no? Yeah. Okay, now cos 2 theta cos of 2 into pi by 2 minus sign here, and next will be cos 0. So minus r by 4. This will be cos pi will be minus 1. This will be minus 1. This will be altogether r by 2. So where the center of mass of this will be? It's telling it will be at r by 2. What do you mean by r by 2? For hemispherical shell, the plane diagram I'm showing it. So the center of mass you just indicate by star. This is r, it will be r by 2. Okay, remember at many places in numericals, no, when we go for the next chapter, we need center of mass of hemispherical shell. If you don't know, you are supposed to revise all these things. I think what is the best thing? Better remember, no? I suggest you like there are some around 16 to 15 objects are there. For all those objects, you should know where center of mass is. If you remember well and good, it's very easy, no? In exams. But the mathematics involved here will help you a lot in the total coming physics. There is a reason why I am stressing. So for hemispherical shell, where it will be at a distance r by 2 from the base, or you can call also from the curved surface r by 2, anything, because the radius is r, no, r by 2 from the curved surface or r by 2 from the base. Hope yesterday I insisted like go to the kitchen, see so many vegetable, fruits, you have glass, spoon. For every object, try to make a guess. I'm not asking you find out where can be center of mass, what elemental structure you can assume. That's all. No need to solve anything. Just observation is needed for us. Okay, look at. I'll scroll down. We'll take the solid hemisphere, center of mass of solid hemisphere.
Sir,
Ah,
sir, one scroll up.
no need, ma, no need. I'll send PDF. You can go for check that one. No, go for solid hemisphere. This is what it looks. So radius is so everything the mass is present. And the mass is present everywhere. Half of the lemon, half of the watermelon. So this will become base. This is a curved surface. So here we define density. Rho will define it. So you define density mass by 2 by 3 pi r cube. Volume density we are going to define. Half of the lemon. So what is the solid hemisphere? Half of the watermelon, half of the lemon is what? The solid hemisphere. When you squeeze that lemon, everything will become thin surface. So here there won't be any solid part, no. So then that will become like a hemispherical shell. We have to calculate the center of mass of this from the base. Okay, we have this is the plain diagram. I'll give it. That will help us a lot. Okay, this is the hemisphere of radius r. It is. What elemental structure we should assume?
Discs.
Yeah, you can try it. Then. I'll prefer to go with the hemispherical shell. So here we have two things. One, radius r. This is not needed, no? Now what I assumed is the elemental structure. What we assume? Okay, this is no. Okay, this is solid hemisphere, and I'm asking you thin hemispherical shell. You can also choose disk, very lengthy integration. This is what advisable. Thin hemispherical shell. So thin hemispherical shell of radius r. So where do its center of mass will be? Exactly at r by 2. Center of mass of ohm. Center of mass of thin hemispherical shell, not of the solid hemisphere. Solid hemisphere, we don't know that. So I'll call this as C1. So where do it should be? At r by 2. This is, I think, OC1. What is OC1? Should be equal to r by 2. So what is C1? C1 is center of mass of elemental structure, I'll write it. Thin hemispherical shell or elemental structure it is. No, first we should define the mass of that one. No? So let the thickness of this be dr. Mass of that be dm. So what is dm should be equal to density rho. What is surface area of hemispherical shell? 2 pi r square. Thickness is dr. What is rho? Rho is m by 2 by 3 pi r cube. 2 pi get cancelled, so 3m by r cube r square dr. Then what is our definition? YCM. First YCM of what? First what is the definition? The center of mass of hemispherical shell OC1 into mass of hemispherical shell by total mass. OC1 should be equal to r by 2 dm 3m r square dr by this will be total mass. The limit should be 0 to capital R. So then further YCM is equal to m get cancelled, so 3 by 2 r cube r to power of 4 dr.
R cube.
R cube, okay, then r cube I'll make it. So then this will be r to power of 4 by 4. So altogether 3r by 8. Where it will be? It's telling for solid hemisphere it will be at a distance 3r by 8 from the base, because what is y equal to 0? The y is what we defined it from here. This is y-axis, simple. 3r by 8 from the base. Coming chapter, rigid body mechanics. So many numericals just revolve around this one only. Center of mass. So where it is? 3r by 8. You take watermelon, cut into two equal parts. Then where the center of mass of watermelon, half of the watermelon will be 3r by 8 from the base. Base means the flat surface here. Please do remember, very important, at so many numericals we do in the rigid body mechanics, we need just this information. I wanted to write all these formulas just here, but students, what happened, this assuming elemental structure is something very essential for the coming part of physics. That's why I'm just focusing on how to assume different elemental structures. Make observation. 3r by 8 from where? From the base it is. I think in every numerical, identifying elemental structure, then defining the mass of that elemental structure, then defining the center of mass of that elemental structure. I think matters a lot here. So what is C? C is a center of mass of solid hemisphere. I'll scroll down. No, after this we'll go for solid cone. Everyone knows solid cone. Solid cone of height h and radius r. Don't wait for my diagram. Hurry up. No, there's everything is a solid cone. Height h and radius r. You can place it vertically or any orientation. Okay, this will be radius r. This will be height h. Let the rho be the density. H is the total height. We'll indicate here. Carry on now. Solid cone density will come into picture. What is the first thing is like what elemental structure you can assume so that you can get into the problem solving. I'll assume a circular disc. We have to assume a circular disc here. No other color. Yeah. So we have to assume a thin circular disc of radius y, thickness dx, let it be at a distance x. Then the mass of this element be dm. This is a elemental disk it will become. Such elemental disk of increasing radius from 0 to capital R will get the solid cone. We'll define this cone angle. Okay, first I think let's get into the some basic mathematics involved here. What is the density? How we define density of a cone? Volume of mass by volume of a cone. Volume of a cone pi r square h by 3 or 3m by pi r square. This is the density of the cone. Then next we'll define what is a dm. Mass of the elemental disk. Density, what is the area? Disk, no, it is disk, and thickness is how much? Dx. Density into volume of the disk, pi y square dy dx. Dx is thickness here. No, actually the disk is what, like it is not a complete disk. Hope you might have made noticed here. It is actually like this, no? Since it's a solid, we can assume it to be this one. Actually there's a slant length will come. This is a slant length. Since it's a solid, we can do approximation. So here we'll assume some amount of mass is present. We'll make it like a uniform disk here. But look at the radius of the disk. Here it is r. At the bottom it will not be r. But what is the thing? As it is a thick, this additional volume what you add doesn't matters. For solid cone, this is approximation. For all the solid things, we do this approximation. Actually, what is the radius y? At the upper surface and lower surface, it will be less than y. But since the dx is so small that we can neglect this amount of mass. Means here, even if I assume some amount of mass as dx is very small, so it doesn't matter. No. Okay, we know rho. So let's go for definition of YCM. What it says, like the center of mass of the elemental structure, where it is at addition 6, I'll write it some other color, into mass of elemental structure by total mass of the system. So this x keep as it is. The center of mass. So here I know where the center of mass of the disk will be. The center of mass of this should be at its center. So what is x here now? Center of mass of elemental disk from the origin. So we'll choose this is origin. Now what is dm? We'll substitute here all the values. Dm will be rho pi y square dx. Rho pi m. Okay, this has come outside. X y square dx. How to manage all these things? Okay, we'll look at the triangle. Look at some triangle here. We have some triangle. This is R, this is H, this is Y, this is X, this is theta. So from the triangle, what all we can write it as? Tan theta is equal to R by H equal to Y by X. Can we replace Y or X? It's left to you. Let me replace Y. Y is equal to R by H into X. Substituting that in, X into, this will be RXH whole square dx. So what is the value of X? Will be X equal to 0. This will be X equal to H, no? What is the overall length of the, what is the height of the solid cone? This is H. So the dx is what we assumed along x-axis here. So the x will vary from x equals 0 to x equal to h. Limits, I'll show it separately. Now this will become rho pi m r h will be outside. This will be x square dx. One more step. So this will become pi rho r mh h cube by 3. What is rho? We have other side. Pi r mhu. What is rho? Rho will be 3m by pi r square h cube by 3. Sorry, x cube. X to power of 4. This is 4. Yeah. I'll change everything.
But that should be r square by h square, no sir?
R square h square. Okay, done here. So here r square h square. R square get cancels, pi r square get cancels, h cube, h power of 4, that also can them get cancels. I think okay, I'll end up with this 3h by 4. Just check once and confirm. 3h by 4 from where? From the apex. From the base it will be h by 4. This diagram will take it. It has to be, this should be the center of mass. Total is h, 3h by 4. Either you measure from the apex or from the base, h by 4. Any reason? Because more mass is present in this region than this one. No? So definitely the center of mass should lie near to the heavier region where the more mass is located. So therefore here is what will get the center of mass. Because you look at this, here the mass is distributed more, no? So therefore center of mass will lie near to the heavier region. I think these are some cross checks what we have to do. most of your future engineering, other than software engineer, what all you pick up now will be of this kind. It's not that easy engineering. You should be very good in application of maths, not mere maths. You should know how to use calculus. That's the only alternative. Of course, to overcome this all these difficulties, we do have softwares here, but you should know how to use software. The minimum basics are needed. Not like software will help you to adjust the calculation, but how to use software, where to use, that also one should know. So this will be very, you can say like the application of calculus is what everything, or better let me say, the application of maths. So not just mere maths, you should know how to use maths. So what you're learning in mathematics is like just you're learning maths here, you don't know how to use it. In physics, slightly we are trying you to explore like a explore of mathematics is what in physics is happening. This will happen at highest level in the engineering. So do you think engineering very easy? No, very tough it is. Your life will become hell, that's all. To become unhappy, what will happen? You are going to become engineer. It's not that easy. I'm telling this on the designing, everything, no, lot of struggles will be there. This one. So at very early stage, that early stage is now this one, class 11, class 12 only. Here only the student has to develop the skill of application of maths. One side, the physics will become easier. Gradually, when you get into IITs, no, this will come naturally for you, how to use mathematics. There you can, little bit, the struggle will get minimized here. So these are some, my experiences, what I'm sharing you. So no sir, let us face hell, let me face hell in the engineering only. Let me be happy now. So choice is yours. Explore of mathematics is very essential. Little bit for computer science, very less, least it will come, only 2% of application of maths will come. Electronic and communication, you need around 40%. The remaining all subjects, the 100% of application of maths. So you should imagine, no, you should have first what happen, how that object appears in 3 dimension. You must know that one. For that, what you should know the physical world. That was the main see, what is the main source for you, for your knowledge. The nature itself is your main source, not the book, nor your teacher also. Who is the main source? The objects around you. Keen observation. How do it look if I see like this? How do if it looks if I view from that angle? This we have lost it. We are now more interested in what, like some fantasy world. Am I right? The fantasy world, the romantic songs. Just listening, closing eyes, you're listening romantic songs. Okay, if you want to become poet or literature work, okay, fine, good, nothing wrong there. But you want to become engineer, no? So how you are related to that romantic songs listening? I don't know. Like I'm not getting logic. How you are related to watch that movies? How you are related? How your career related to them? I don't know that one. Are you getting no? So this is some like a. I'm just trying to brainwash you, like a. What has to be done? What you are doing is right or wrong, because the society has got so much of like a changes in India that it is not suitable to produce best engineers. Please do understand, because as a teacher I should open your eyes. The society where you are living is not suitable to produce a best engineers. So the morning you get up, I think in your home, they'll switch on some devotional songs they play. Afterwards, what happens? Slowly we'll enter into the listening songs, then movies, then serials, then cricket. That's all. The television has become, but since television also you have so many things which are very useful for your scientific empowerment. Are we using it? Not using it. So this shows that you can see gradually, scientifically what we are using. Mobile. Okay, only now what happened online classes we have started using this mobile. Otherwise, what happened? The mobile is best is suitable for game everything. But in mobile, the internet is all about the science. So much of information about the science is there, no? Unlimited. What I am teaching is a drop in that one. So much of information is available in internet. But did we use it? No, we think that mobile is something like a watching some movies, watching some, playing some games for communication. That one. But you do have so much of information mobile. It's a scientific device. Scientific calculators are there. So many tools are there. So many apps are there which are going to help you for your education. Are you ready to explore? No, not needed. Online education also just Zoom app. That's all. So are we really using so many apps are there? No, sit and explore it. These are things what we are missing. So we want just like a science like that only without effort. Yes, there's a problem. For whom you will get a science, the one who has put effort, for him will get a science. So now what is the attitude now? Like in movies, how we get entertainment by watching, like that by watching you want science, not possible. See, please do understand, after this, I think on September 1, we are going to get into offline classes. Your trouble will increase because there won't be any video recording will not be there. So at then and that instant only you should understand. And if you ask me to explain again, time will not be there. Okay, Ken, I'm just going to scribble on the board. You have to parallelly write, think, analyze, understand, interpretation. Totally different offline classes. In schools, we were taught in different way. In the coaching, what will happen here, JE advanced coaching. So things will run so fast that what will happen, uh, your eyes, your brain, your hand, so what happen, all will get synchronized here so fast. And by chance, if you miss one point, gone over. After class, okay, recording, no recording, nothing. You should be so focused. You should be attentive. Things are a little bit different in offline class than here. Here, at least you are not understanding. Okay, fine. Recording is there. You can catch that point. So nothing is there. Then and there only you are supposed to get. If you lose it, again teacher available in counseling. Maybe 1 or 2 points will understand, but the total class gone. If you had not understood total class, teacher not having a time to explain the 2 hours within 10 minutes or 5 minutes, not possible. Okay, slowly, I think change mindset, like all these resources will not be there. Totally different method will be there. Then no online notes. If you don't write, gone. Okay, I think totally a physical world will be there. Slowly habituate yourself for that particular thing. High attentive in class is needed. So now, okay, fine. Offline classes, you should be highly attentive. If you miss some point, gone. Again, teacher, okay, in counseling, if he is helping you, okay, fine, otherwise, gone. If you miss some topic, nothing will be there, nobody will help you. Only somebody, your friends might have written notes, that notes is available. Afterwards, nothing. Explanation, how 2 hours explanation teacher can explain for 1 hour only for you, not possible. Teacher is meant for everyone. So if you miss a class, gone. So many parameters are there. So your offline class demands a totally different skills now. Take it for granted, things will not be available. So high speed writing is very, very important. Okay, now we'll go for hollow cone. This one only hollow cone. Get into the hollow cone of height and radius r. Okay, what is height? Height will be h. R will be radius here. So here instead of rho, Instead of rho, we will define sigma. Hollow cone, you take some paper, make it a cone. That's what the hollow cone it is. Now, get into the elemental structure you assume. This is called a base. This will become apex. Okay, don't get scared offline. For your help, app is there. To maximum extent, you can take help of it if you are interested. If you by chance any fever is there, if you have missed a class, no, you can cope up with that. But it's a temporary. Offline is offline. No equivalent for that. Two different things, online and offline. Offline is having its own advantages, online is having its own advantages. But learning in offline is something natural process it is. Naturally, you're going to learn things. This is like artificial learning. So, what do you prefer, offline and online? I do prefer offline. I don't like online, to be frank. I'll be very happy in offline classes because I'll come to know how you think. No, I'm just looking at screen here now. There, the students, like how do they analyze? How do they're accepting? Little bit we are able to analyze that and we carry on. Let's get into the calculation part. The sigma again. What is elemental structure? Shall we take a ring?
Yes, sir.
Such rings, what happens when you join? You do get hollow cone. Some toys are coming nowadays. They are so good. Like the kid was asked to place one ring upon the other ring. That's all. No. The toys also nowadays are more about. You see, all the toys, lot of science is involved. Please do purchase one car because very much essential. Next, we'll go to the rolling motion. Just purchase one toy car. There is enough that one. Come to the college. Put in your bag one solid cone, one solid hemisphere, one cylindrical rod. Fill up in bag. Some wooden one or plastic one. Come to the college. No, really good because next after this week, rotation mechanics we are going to learn some like a ring, solid plate, not big plate, one small one in polythene bag. You come fill up all that. I'll tell you all the objects. Happily come and sit in the class. You can really manage most of the things what I teach. Purchase one toy car, okay, one cylindrical rod. Better you go for the wooden plastic one. Metal, okay, fine. Just like I said, what should be the length? Don't come with 1 meter, 2 meter. Just like 10 centimeter. This one scale, you go for it. Rectangular plate, square plate, rhombus, trapezoidal plate, then hemicircular plate, circular disc, quarter circular disc, ring, semicircular ring, quarter circular ring, triangular plate. Different types of triangular plates are there. Then solid cone, hollow cone, hemisphere, hemispherical shell. All these objects, then one wire, one thread. So have this one. Purchase means okay, you can make them also. What is that one? So all these are essential for us. One cylinder, cylindrical, I think some plastic one, any can, small one. Just fill up, gather all these things. So as and when, okay, I'll tell you like how we are going to use them. Okay, now this will be our. Shall we call this a disc? No, thin ring. No, it is. So this will be Y. Here two things are there. The dx. dx, and this I'll call it as dr. Or so like let it be dl. So let this slant length be l. Okay, fine. Now what is the mass of that elemental ring? dm, that we should define. First of all, what is sigma? What is sigma? Surface area of a cone. What is surface area of a cone? Pi RL, pi RL. What is L? L is the slant length of the cone. Height of the cone different, slant length of the cone is different. Pi RL. L is the slant length of the cone. Okay, now we'll define the dm. Sigma into the mass of sigma into 2 pi y into dl. What is y? Y is the radius there. dl is the slant length. This one, you should not write dx here. So now further, the sigma, write it as pi RL 2 pi. I should replace this y and dl. So again I'll take help of this theta from the triangle. This x, will define this one. So what is sine theta? Y by L. And also we can write it as R by capital L. So y is equal to L sine theta. Let me take help of that. So this will be m 2 pi m pi RL. Y is L sine theta into dl. Sine theta, can we define anything sine theta? R by L, already have that one. So pi get cancels. Let me cancel all the terms. Sine theta, we can write it as R by L. Pi get cancels, so 2m, R get cancels, L square, L dl. What is slant length? Okay, there's only YCM, no? No, come for this one. Oh, sorry. This is a DM. Now we'll define what is YCM. Where it is at a distance x, the center of mass of this elemental ring will be at a distance x from the origin, from the apex. Then mass of that is dm by total mass. X keep as it is. dm is what we derived, and that is equal to 2m L square L dl. M get cancelled, so 2 by L square x L dl. What to do with x now? X is there and L is also there. X and small l. Small l, okay, we can replace that one. There is no problem with that one. So we'll try to replace x in terms of l.
X is equals to L cos theta.
Yeah, that's all. Okay, we'll do one thing. Cos theta equal to x by l. What is cos theta? We can define cos theta. We can define as h by l from this triangle. So therefore, this will become x equal to altogether. Okay, now finally, what is x is equal to? L into cos theta will be h by l. Let me substitute that x there. YCM 2l square. This will be small l, capital H, L into dl. 2 h l cube l square dl. What should be the slant length? Should be equal to L, the limit. YCM is equal to 2h bar L cube. This will be h cube by 3. Sorry, L cube by 3. 2h by 3 is what? The YCM we are getting. I think I'll write XCM. Because along x-axis, no, it will be. So where the center of mass of cone will be? Center of mass of cone will be again in terms of height, slant length what we have. So this will be the center of mass of cone will be 2h by 3. From where? From the apex. So h by 3 from the base. You have to remember this. I think nobody will ask you to derive. Nobody will ask you to derive. If you remember well and good in numerical, directly you can start with this data. Okay, this is about the various shaped objects is what I am showing it. Just make observation. Okay, now we'll take some other. These are some structures I shown. So again, what are left over? Some pyramid left over. You try to think over them. Put some effort and try to manage few other shaped objects on your own. Let me go for some other types. Some if
Sir, one
some.
minute, sir.
Let's take the next set of problems. If some hole is made in a circular disc, these are some questions we have. So I have this is a circular disc. In that, some hole is made. The hole I'll denote by this will be the radius of the hole. This is a hole. Radius of this be r by 2. Radius of this, let it be r. This is having a mass m. This is a circular disc. Where do its center of mass will be? After making an hole, let O1 be the center of mass of the circular disc, O2 be the center of the hole. R by 2 I am showing. What is R by 2? R by 2 is the hole. I think you take paper, you just make a hole. Find the center of mass of this system where an hole is there. What is m? Mass of the disc with hole. Find the center of mass of circular disc if a hole of radius r by 2 is made in a disc of mass m in a disc of radius r. Let m be the mass of disc with hole. We have to locate the center of mass. We know for circular disc where the there's a question. No, let me make the diagram small. No. We know for circular disc it will be at center. If you make some hole, so now where the mass, the more mass is present in this region than this, so center of mass will not be at center. Will shift it. It's going to shift this one. So we have to calculate now the new position of center of mass. Without disc, without hole, the center of mass will be at O1. When you make a hole, center of mass will shift here. So the new location will be somewhere here. That we have to calculate. What is the method like to solve such problems? So first, this. You have some, this called like some, look at the advanced paper. It's called like a cavity concept. That's what we are going to teach now. Again, going to get repeated in some 6 chapters where all like a moment of inertia, gravitation, heat transfer, then electrostatics, capacitors, resistors, electromagnetism, induction. So at all these places, elasticity, the same topic what we are going to discuss now, the same idea is going to get involved. And if you check the advanced paper, this is called like a cavity concept. In one of the advanced paper, there were 7 questions based on cavity only related to different topics. In that year, if a student has understood this cavity concept, this is called like a hole or cavity. If he has understood the cavity concept in any one of the topic of that 7 chapters are there, he is able to manage all that 7 questions. He was able to manage all the 7 questions. So there are some interrelated one are there. So at least put effort now. The coming chapters, so you can feel very easy. So this is what we should assume. So what is suggesting is like you can assume this now. This circular disc with hole is equal to circular disc without hole, and this is the hole. This is a circular disc with hole. So shall we assume that one? And I'll assume that this to be made up of positive density, this to be made up of negative density. What is the mass of this now? We don't know. This is m1. We have to calculate. This is m2. You subtract this here, then the absence of that will become hole. The hole I'm showing green color. this when you add up here, I think that there should be some other color, no? I'll bring some other color. This radius is r by 2, O2, M2, the density will be, so this is the hole. Now when you bring this negative density and keep it here, positive density, negative density will cancel out. What do we get? We get a hole. Hole means nothing is there. Just take paper, make hole. Then how can I assume that hole? Like a disk without hole, then a disk. So what is this? A disk with a negative density. Positive density, negative density will cancel out, will get a hole. I think this is on paper. Practically nothing will happen. You take one more disk and keep it on other thing, no, nothing will happen here. We are on paper, we are telling plus sigma minus sigma here. The density will cancel out and we get a hole. So here afterwards, like a lamina, this is called like a lamina with a hole. How you to assume? Lamina without hole plus hole. So when you add up both, you get a lamina with hole. Shall we calculate center of mass of this S? Shall we calculate center of mass of this S? Then we'll take superposition, we'll get the required answer. First, what is M1? For that, we should know the sigma for this. What is the sigma? How you define? M by pi r square, pi r by 2 whole square. So this will be 4m by 3 pi r square. This is the area density of this circular plate. Because in pi r square you are going to remove this particular, there is no mass here, no, so you should subtract that area where there is no mass is present. Then can we calculate the m1? What is m1? m1 should be equal to sigma into pi r square. So this will become 4m by 3. This is the mass. What is m2? m2 should be equal to minus sigma into pi r by 2 whole square. Okay, let's get into center of mass. I'll where the center of mass. So we'll do one thing, sir. Where you are going to take the origin? Let me take the origin here only. Mass is m1, and where it will be located? At origin only. Because where the center of mass of this particular this with hole, without hole, will be at its origin. So you write it here. Or if you want, you can take the origin here, left to you. Let me choose this itself with origin plus m2. Right, what distance it is? It a distance of r by 2 here. Substitute m1 and m2 with sign. So this will be 0. m2 is how much? Minus m by 3 into r by 2 by m1 minus r by 6. I'll get it. What do you mean by minus r by 6? Where it should be? On the left hand side, because I defined this is x equals 0, no? No. XCM, I'm getting minus r by 6. So where the center of mass of this system must be? It must be on the left side of the origin open. Size, some size I should increase, huh? Okay, fine. I can't write all the things, huh? Let me try. Visible properly. Okay, no. So where the center of mass of system, I have to show it. Let me take this. So it will be on the somewhere r by 6. This will be center of mass. R by 6. So O1C will be R by 6. So where the center of mass, definitely according to the concept we know, it should slightly shift to the left, no? And how much of distance? R by 6 here. If you uh, like this, if any all if you see, no, there's a method is what you should apply. I think complete description is there. This is very important. This is the first time you are seeing. When all or cavity comes, you should bring the idea of negative density. The positive density material, negative density material will cancel out. Practically, there's no negative density material. This is the superposition principle is what we are bringing here. You can make this hole in any plate. In square plate, you can remove some hole. Where all you want, you can remove it. This is called like a hole, which is not called cavity, because for lamina, the absence of mass is called as a hole, no? I think we do represent like this. I'll scroll down. Next, we'll take the structure. Cone is needed. In solid cone, I'm going to remove an hemisphere. So what we are doing in a solid cone, we are removing that hemisphere of radius r, where the center of mass of the system will be. So let this height be 3r, radius of this be r. Then let me define the rho be the density of this one. In a solid cone of height 3r and radius r, a solid, so like a hemispherical cavity is formed as shown. Find the center of mass of system, and this is called like a hemispherical cavity. Are you able to understand? I'm just going to remove a part. So in the solid cone, there's some hemispherical part is removed here. So that will become a hemispherical cavity. Now you should not call this as the hole. In 3D objects, the absence of mass, cavity, I think all of you know, cavity means hollow part. In the solid structure, any hollow part is called as a cavity. I think a tooth cavity we call, very simple. What is the reason there? The calcium part was eaten by the bacteria present there. So we call the absence of the some like a bone or the in the tooth, that hard part is what we call cavity, no? Same thing here. So now what is the shape of this? Hemispherical. So we'll call hemispherical cavity. You may get spherical cavity, placed like in a cube. I can bring a spherical cavity, no? Conical cavity means like this. Hemispherical cavity like this. No mass present here. Solid, there's a solid, and here no mass is present. In 3D objects, the absence, the region where the mass is absent is called as a cavity. No. Okay, work out here, no? So what is the assumption has to be done here? So this particular structure, what we assume is it is equal to cone, solid cone, same diagram. Let me adjust this structure. It is not coming. No, okay. Everything is a solid. It's a solid cone. Are you getting? No. Now I am going to remove a solid hemispherical region in this. Then it will become a solid cone with hemispherical cavity. So this is the this. Let me shade it here. When I put this negative density hemisphere in that solid cone, so definitely what do I expect? The positive density, negative density will cancel out, and finally what do we get? We get a solid cone with cavity. So what is this? Solid cone with cavity. Solid cone without cavity, and this is the solid hemisphere of negative density. Hope are you able to get this? So what we know, we have to calculate this mass m1 and m2. These things are needed. Directly the given density. So how to get the rho? Now first, what is m1? m1 should be equal to volume of the cone, rho pi r square h by 3. What about m2? Minus rho. Why negative? Because there's a absence of mass, no? When I keep this here, plus density, positive density, negative density, the material will cancel out, then we'll get this a cavity here. So this is the cavity. Now this should be 2 by 3 pi r cube. Let's get into the YCM is equal to m1. What is the center of mass of solid cone? From the base, from where we are measuring, we are measuring, this is y equal to 0 from here. This is x-axis. Just now we have studied, no? I think, see, these are the numericals. Nobody will ask you derive center of mass of cone. The application problems like this, if you don't know center of mass of solid hemisphere or solid cone, I don't think so in exam you can really manage anything. H by 4 from the base, 3h by 4, 3h by 4 from the apex. From the base it should be h by 4. Like this, see, why I suggest you, see, memory of what kind? Memory of this standard derivations. What all we learn, no? So those things you should be able to analyze and remember. What is h? We don't know h. H is nothing but 3r by 8, no? this only I'll call H. Okay, this will be by m1 plus m2. Somebody please mute it. Okay, now substitute all the values. What is m1? I'll push these things here. Okay, now we'll go for calculation. m1 rho pi r square h by 3. This is h by 4. m2 is minus rho r cube 3r by 8. m1 rho pi r square h by 3 minus rho 2 by 3 pi r cube. What is h? H is given, no? 3r. Substitute and solve it. Anybody give me answer? H you have to substitute 3r. So rho pi r square will anyway will get cancelled. Check it. Rho pi r cube will get eliminated. Let me go for it. Rho pi, now present rho pi r square by 3, I'll take it out. So I'll be left over with h square by 4 3r cube r square, sorry, divided by rho pi r square. We have taken out that h minus 2r. So what is h square? 9r square by 4, 3r square by 4. H is 3r minus 2. (1.5r). Check once calculation.
One 1.5 hours, sir.
Yeah. So now in any object I can remove any other shape, no? So you have quite independence are there rather than fighting with the book, no? Just like take some solid object, in that you remove some well-defined geometrical shape, then where center of mass can be. So it will be somewhere at this particular point, it will be 1.5r. Center of mass, no, you just indicate this is C1, C2. Center of mass of this solid cone with cavity, with hemispherical cavity, will be at a half of the height. I'll scroll down, we'll take the next one. No, I can have a more than one object can be present. Take the next. solid hemisphere. It may not be perfect diagram. Try to adjust. I have kept like this. So this is the solid cone and this is the solid hemisphere. The density of this is 2 rho. The density of this is rho. The radius of this is r and the h is the height. Now I want the center of mass of this system to be at the common base. So shall we call this is a common base cone, and because what I placed, I took a cone of height h and radius r. I placed it on a hemisphere of radius r. Then this will become a common base. The structure will become like a common base here. So now what is my question, like what should be the relation between h and r so that the center of mass of system will be at common base? So you will get a solid cone is placed on solid a solid hemisphere of radius r. Find h by r for the center of mass of system to be at center of common base. This is a condition. So where the center of mass of system should be at C. For solid cone we know will be somewhere here and the hemisphere will be here. Now for together what will happen? It should be the of the system, it should be somewhere here. So how that h and r are related? That's what we are trying to find out here. Like that, more than one object will be come in contact, and they'll put a condition that the center of mass of system must be here or must be here. So we should now get into the calculation. So where the center of mass of solid cone, h by 4, we know it, that of the hemisphere 3r by 8, and let me define this is x-axis, this is the y-axis. The center of mass of system must be at origin, so we'll go for it. YCM equal to mass of this we don't know, m1, mass of this m2. m1, so this will be 3h, sorry, h by 4 from the base, m2 minus 3r by 8 by m1 plus m2. Why negative sign here? Because the center of mass of solid hemisphere will lie below the origin. So minus 3r by 8 will come. Then this will be, what is m1? Density 2 rho, volume of cone pi r square h by 3 into h by 4. What is m2? Solid hemisphere, density is rho, 2 by 3 pi r cube. This negative sign, let me write it here. So 3r by 8 by m1 plus m2, rho pi r square h by 3. This should be equal to 0, no? Why YCM should be 0? Any reason for this? Center of mass of system so why you are assuming like this? Not assumption, the condition itself is given. where the center of mass of system should be at origin, and that origin is nothing but the common base. In the bracket you write origin. Okay, fine. Okay, now we have to solve for h and r. So that I think we can take out rho pi r square by 3 common. 0 is equal to 2 rho pi r square by 3. H square by 4, 3 r square by 8. Yeah, okay, this one. I think some problem. 2 row and row. Anyway, they'll be multiplied with 0, no? H by r is equal to 3 by 2. If the ratio of h by r is that much, the center of mass of system will lie at a common base. So many toys are there, no? Some toys, there, no? When you push it, it will oscillate, it will not fall. There we need all these things. Huh? So there are so many toys are there. We need all these basic things. Manufacturing of toys. Do you think that India is good? Very poor? No, we do import most of the toys. No, only 1% of toys what we manufacture, what all we have in India selling. The reason for that, we don't have science. And that's why the government has initiated manufacturing of toys, because now I have kids. One I think is in for like a 6 years, other is 12 years. So definitely I think I do purchase toys for them. And the manufacturing of toys, we need lot of science here. And we are very poor in science, that's why we are importing. Are you getting? No? So there are so many issues are there with us. No? The basic science, we are so poor, the application part, everything, no? We are unable to manufacture the toys. Okay, of course, we just do copycat, but the new toy is something not possible. We need lot of science.
Sir, what happened to the denominator?
Hey, multiply with 0, what will happen?
Okay, yes, sir.
Okay, that one, see, like we have a lot of L of problems in our nation. For what is the root cause for all this? Lack of knowledge. I'm telling this one, the lack of knowledge only. Means, sir, like, what do you mean by lack of knowledge? Yes, students are very good in what? Like, remembering, not analyzing. Students are not good in what? Like, solving problems. Students are like a parasite. Parasite means they just depend on teacher. Teacher will explain, they listen, question will come, they'll solve that question, finish over. Any individuality from student, nothing is there. So as long as students are parasite, not possible. Knowledge will not come. So we are at a very dangerous situation. Such a big country, we don't have good thinkers. Very few are there. So then what is the root cause? Root cause, I'm telling this one. The root cause is like we don't want to think. How many of you really interested to fight with a question? Question not coming. Let me solve. Let me try. Then again, when you are going for bathroom, thinking that question. When you are eating lunch, thinking on that question. Like this constant thinking. How many of you really want to fight it? This is what needed. Okay, doubt is there. Okay, Sridhar sir is there. Okay, counseling 9:30 to 9 today 9:15. 9:15, 10:15. Sir, send question in WhatsApp. Just read question. Unable to solve? Okay, send it. So these are the fighting ability with the science is very important. Okay, try it 1-2 days. Then okay, fine. I can never solve this. What is the idea? Finish all. And some of you outlapen, sir, solve it. They're not asking the hint. You see that one. What you are doing actually, you are just gathering solution. That's all. What is the use of this learning? I don't know. Like, so just give an idea how to solve this. Let me try. This should be the method. Sir, like, yes, please solve it. Okay, teacher will solve. What is there, that one? And you just get a solution, you feel happy. Okay, now I got the answer. No, there is some problem is there. Where is the effort? There's no effort. So you're not training up your brain. Physics is very essential. Physics, I don't know other subjects, how they will train you up. I don't know the methodology, but in physics is like the parasitic approach is very dangerous. As good as you are not learning. And physics is some very core fundamental thing for engineering. See, my duty is to get you a thinking brain, no, not like supplying solutions. I should not supply solutions. Have you come here to just gather solutions? No, you have come here to learn, no. So therefore, if a question has come, no, please solve it, no. So please send solution, no, don't put comment here. So please give idea. Just only idea enough. I will try it. This should be the approach for a subject. Hope slowly you have to develop the thing. Slowly you have to change your mindset, everything, so that scientific analysis has to be imparted. There's no other way. Let there be sleepless nights. Let there be struggle. Let there be pressure. Lot of pressure. Let it be there. Some people may call you have gone mad. Let it be. But there should be struggle. There's only alternative. There's nothing, no magic, nothing, no temples, no mosque, no church, no guru. Nobody will be help you. No teacher, nothing. You read question, put effort. Read question, put effort. Draw diagram, think it, read it, analyze it. There's only alternative available for you to become engineer. Remaining all are secondary. If you take help of secondary, there's a damage for you. The primary is what? Your brain and your thinking ability, that's all. Remaining all teacher, institution, these IIT institutions, all they are secondary. The more help from them, okay, the more problematic your career. The less help from them, the more better future your career. Are you getting, no? This should be the motto. Okay, now we'll go for some other shaped structures. Okay, some structure I brought it. Here, let this be parabolic plate it is, where this particular shape is given by y equal to x square by 3. Y, this is x. No, so let this be 2. Okay, this will be, I think, 2 will take it. You have to calculate the center of mass of this parabolic plate. Only that curved part is what he has given. Where the center of mass of this, very essential in most of the machines what we day to day use, in the mixers, in the fan. Different shaped structures will be there, no? What is the assumption we have to do here? So the assumption, better the assumption is what? We'll take a strip. In this one we'll take a strip. We'll see where do we'll end up. And this be the mass of the strip be dm, and let the height of the strip be y. And let the strip be at a distance x. Hope all of you seeing the strip. That's the best thing, no? What we can assume? No. Now, what is the mass of the strip? So go back to some integration. We had some discussion of these things in the integration. So XCM. First we'll define the dm. So what is the dm is equal to? Sigma is what given for us? Sigma into y into dx, sigma into dA, y into dx it is. What is y? Y is what? We already defined it. I think let me have this one. So let's go for first the XCM part. X coordinate of center of mass I'll calculate. So that should be equal to, at what distance the center of mass of this strip will be? Definitely at a distance x. So here the strip at what distance it is from the origin? At a distance x. So therefore this will become x. Mass of this be dm into total mass. Okay, this will be, let it be d. What is dm? Sigma y dx. Now what is dm? Dm should be equal to sigma y into dx. Sigma gets eliminated. X y dx y dx. What is y is equal to? X square by 2 dx. 1 by 2 get cancelled, so x cube by dx, and this will be x square dx. This will become, what should be the limit? Till where the mass is spread from 0 to 2. The mass is present from 0 to 2. Go for it. No? So this will be x to the power of 4 by 4. Anybody value? 3 by 4 will be there. I think only 1, 2 will come.
3 by
3 by 2 or 1.5 meter. This is in the center of mass of this will be there, that one. Similarly, y coordinate also we can find out. So in that case, what you should write, ycm is equal to y into dm. So here it should be y by 2. But again, you should define this their length also. Here, the y is defined only for this length. So you should take the half of that one. So you should know this particular length also. Just have an idea. Some parabolic plate. For parabolic plate, we define the center of mass of system to be like this. XCM it is. Can we go for triangular plate? This is about parabolic plate, so we'll go for one triangular plate.
Sir, here can we write the center of mass of the strip as x plus dx by 2?
You don't know integration. What do you mean by dx? No? Why you don't want to learn things? Huh? What is dx? Why you don't want to learn? There's a primary question I'm asking. What do you mean by dx? Infinitesimal length, no. What do you mean by dx? Very, very, very small, tends to 0. Whether you divide by 2, divide by 3, divide by 4, what do you get? It remains dx only. Science is very important. Don't remove science from your learning. Huh? Okay, make observation. We'll go for triangular plate. Okay, triangular plate, I think most of you are aware of it. carry on. Triangular. For your equilateral triangular plate, I'll bring it. It will be easy for equilateral triangular plate. YCM you have to calculate. Why I should calculate? You should put effort. Okay, carry on. Triangular plate of side length L. I think this, okay, this appears equilateral triangular plate. Carry on now. Hope everyone got the method. Your teacher has shown so many objects, how to assume elemental structure, everything. That has to be applied now. Now you should not get scared when you look at some object or some structure. So what is the primary thing? What is the elemental structure? Then what is the mass of elemental structure? Then in the formula, YCM or XCM, RCM is equal to R into dm by integral of dm. There's the one basic idea, no? RCM. What is R? R is the center of mass of elemental structure. Position of center of mass of elemental structure from the origin. dm is mass of elemental structure. I think this is some, almost in every numerical, this is what happened. So now there's a triangular plate. We should assume elemental structure. What elemental structure? The side length is L. L by 2, and this L. The best elemental structure we can assume is a rectangular strip. Some rectangular strip. You may not agree with me, because this will be the natural problem of students, like they don't trust teacher or they don't have faith on teacher. So at least the books what you have purchased with your own money, so some sort of affection will be there on the books, if not on teacher. Just scroll all the pages. You get so many diagrams where what all today I have drawn, or what all from yesterday I have drawn, no? All hemisphere, solid hemisphere, cone, ring, circular disc, all these structures, only what you see in the total physics. So a better picture of them will definitely help you a lot. Can you this one? Just analyze what is there. Now this is the dm. We'll write it here. Mass of this strip. So it's a triangular plate, no? So sigma area density will come. So then if you look at the triangle, this will be theta. This was the strip here. You should have all this. Y will take it. This is H, we don't know. Okay, this angle should be 30 degrees. Equilateral triangle. No. So we don't know H. H is needed. That's why I'm just going for it. Tan theta equal to L by 2 by H. H equal to L by 2 tan theta. One by root 3 tan theta. So this will become L root 3 by 2. This is the height of the triangular plate. So then we can define the mass of sigma. How you define sigma? Mass of the plate, let it be m. So sigma is what we'll first define. Mass by area. Area will be H into L by 2. So what is H? H is L 2m okay, this is going to help us here. Now dm, how you define? Dm will be sigma into area of the strip, rectangular strip. Sir, like, are you sure it's a rectangle? Dx is so small that we can treat it to be like a rectangular strip. It is a trapezoidal strip, I know, but the dx is so small that we can neglect this part. Yeah. So we can make it to be a rectangle. So 2y into dx it will be. Okay, this is about the dm, but we don't know y and x, so many things are there. So let me take help of this triangle. Tan theta equal to y by x. What is tan theta? 1 by root 3. Substitute them all. 2 sigma y is x by root 3 dx. Then we'll take help of our formula. Then xcm is equal to x into, what is x now? How you define x? Center of mass, the position of center of mass of this elemental structure. Elemental strip. So what is x? Position of center of mass of elemental strip into dm by dm. What is x? X will keep as it is. dm is what we derived it, no? 2 dm is the total mass, that will be as it is. Now 2 sigma m root 3 x square dx. What should be the limit? 0 to h. H cube by 3. So I think we have assumed so many things. What is sigma? 4m by root 3 L square. What is h? H is L root 3 by 2 whole cube. 1 3 also there. Anybody value xcm? Because side length is given, no, so therefore we are bringing h. I should not go for h because h is not given. Side length of triangle is what will be given for us. Anybody value?
Root 3L by 3.
Check once.
L by root 3.
L by root 3, ma?
Yes, sir. L by root 3.
Let me check my calculation. L by 3, huh?
L by root 3 only, sir.
Yes, yes.
L by 3.
L by root 3 only.
L by root 3.
Here root 3, 1 will cancel out. Okay, here root 3, here 3 will come. Here square is there, no?
There 3 root 3 will come.
Cube steps.
Yeah, 3 root 3. This 3 will get cancelled. Yeah, fine. So here 2 is there, here 2 cube is there, no? Here 4 is there. 2 4 is 8, okay, this will get cancelled out. Yeah. L by root 3 only. Like this we can define. Side length is given. Height of the triangle will not be given. That's why we are going for replacing h by L. Make observation. Okay, completed. Now, along with this plate here, in this plate, if I make a hole, I think you can bring the idea. In this plate, if I make a hole, I think you can easily bring the idea. Then you know center of mass of the plate and the hole. Then the same negative density idea you have to bring it. Like that, in triangular plate, you may encounter hole like a circular hole or square hole or another triangular hole. So please do put effort to solve such problems here. Now we can also go for a triangular frame. That is about this one. Last one more. Triangular frame. Triangular frame will be we take like this. We have to get the triangular frame, equilateral triangle. Let's make the problem simple. Of side length L, mass be M. Where the center of mass of this will be. Okay, all of you, triangular frame is different, plate is different. So the mass of this plate, triangular frame, find.
Equilateral triangular frame.
Yeah, find the center of mass of triangular frame of mass M and cell length equilateral. I'll write it. How to bring this? Now, what is the method? So, where the mass of this will be of this rod, because the triangular frame is made up of 3 rods. So the mass of this rod will be at the midpoint. Mass of this will be at midpoint. This will be at midpoint. So here we have to now bring the mathematics what we had. System of particles similar to that is what you have to treat here. So don't show rod now. In place of rod, bring the center of mass of the rod. So this will be the center of mass of the first rod. So mass will be m by 3. Center of mass of this will be m by 3. Center of mass of this will be m by 3. And this is the origin. So this angle is 30 degrees. This length will be L by 2. So can we calculate this and this one? I think problem will be solved. Tan 30 is equal to y by L by 2. So y equal to L by 2 tan 30. So L 2 root 3. Sin 30, sorry. Sin 30. L by 4. Similarly, cos 30 is equal to x by L by 2. So x equal to L by 2 cos 30 degrees, root 3 by 2. So L root 3 by 4. What should be our formula? Now what we should do after this? Center of mass of system of particles. Already you have seen in that cone and hemisphere, the similar approach is what we should develop here. Okay, I have a place to scribble. We'll write it here now. First we'll calculate x coordinate. X coordinate will be m by 3 into x, m by 3 into x plus m by 3 into the height of that one. Anybody, height how much will come? Height of the angle, no? L root 3. M by 3 plus m by 3 plus will get eliminated. So 2x plus L root 3 by 2. So what is the value of x? Already we know it. So L root 3 is what? The position of center of mass. Y coordinate of center of mass. Should be 0. Y coordinate of center of mass should be 0. So where the center of mass of this triangular frame will be. So shall we, what you can call that L by root 3, anybody? Is it a centroid something?
Yes, sir.
Yes.
I think it should be a centroid, no? If you draw a medians, produce that medians, no? So this, it will be at the centroid of this triangle is what center of mass of this triangular frame will be related. So I think some observation is needed rather than some blind approach. Axiom is needed. So what is axiom now? So I'll just conclude here. Center of mass of triangular frame will be at centroid of triangle. Okay, you get plenty of things of these kind, so please do think on them. I have shown few of the examples, so you have to explore all the things. Okay, I'll end up the class. Okay kids, like we had the discussion on the determining the center of mass of different shaped structures. So today we have seen like some sort of a frame, then some 3D object, then we brought some lamina also, laminar objects, then we brought some hole in some laminar object, then again cavity also we have brought it. So these are some types of numericals are there. Please do put effort. All these are geometry based. So in the coming part of physics, this way of thinking, this integration, assuming elemental structure, they're going to play a vital role for you. Very, very essential. As far as exam point of view, may not be important, but as far as your learning part of physics, these are essentials. These geometrical skills you need, these integration skills you need. So all of you focus on these things. Work out problems on location of center of mass of system of particles and center of mass of different shaped objects, and combination of objects with some hole is present in laminar body, with some cavity present in 3D objects, where the density varies. Think on them. Okay, I'll end up the class. Thank you all of you.